Okay, it's going.
Okay, awesome. Oh, shoot. I don't know why it does that. Does yours, when someone's calling my phone, it starts ringing on my computer.
Oh, right, yeah.
Weird. Okay, I think I got it. Okay, I can do the first one.
Okay.
What does it mean to have matched pair data? It involves only one population and a pair of observations is drawn on the individual selected for the sample.
Yep. Let's see. Wait. Are we on lesson 13?
Oh my goodness, did I do 12? I thought we were supposed to do 12.
That was on Tuesday.
Oh my goodness. Shoot. Well, I did that. Well, you can just go through it and I'll open it up.
Okay.
Right now. Sorry, shoot. Of course. I told you I'm out of it. I thought I was doing the right one too. I had no idea. Because I missed Tuesdays. So anyways, go ahead.
So what is the difference between matched pair data and independent samples? So in independent samples, well, you just read what was matched pair data. So in independent samples, there's no pairing between the groups. So you have different groups, two different sample groups and independent samples. And then for number 2, it says complete that chart. And that's just, so what you're doing on for number 2 is you're doing the hypothesis test for one mean with sigma unknown, a hypothesis test for 2 means with paired data, and then a hypothesis test for 2 means with independent samples. And then just filling in each of the requirements, and then what you would do for a hypothesis, the null hypothesis and the alternative hypothesis.
Okay.
So that's kind of a lot of work to do that on.
Oh, wow.
I mean, it's not hard, but it's like, you have to, yeah. Put in your hypothesis, your null hypothesis, your alternative hypothesis.
Right.
So in part 2, one of the professors of the BYU collected data.
This is kind of the same as.
Sorry, what was that?
I was trying to say this is pretty much the same as lesson 12, right?
Pretty much the same, except for we're using independent samples.
Okay.
Gotcha. So they're collected data from BYU Idaho students to compare the mean wages of BYU Idaho male students to BYU Idaho female students. And the students from his classes completed a survey, which he then used to analyze if there's a difference in these wages. Oops.
I found it.
Apparently, Siri thinks I'm talking to her. So if you want to open up the class survey data,
okay,
then we can walk through it.
Okay.
If I can remember how to do it. I did it late last night.
Let's see.
But while you're opening it, I'll say, what is the research question? And so the research question is, what's the difference between the mean wages of BYU Idaho male students and BYU Idaho female students?
Cool.
And so then the null hypothesis is that the mean of male students equals the mean of female students, or group 1 equals group 2, and the alternative is group 1 does not equal the mean of group 2.
Okay. Okay, what was this called? Class survey. Yeah. Should put it. Oh, there it is.
Cells.
Okay, I have it open.
I'll see if I can remember how to do it. Um, sorry, mine's being slow. Okay, so we first need to get our mean and our standard deviation and our sample mean, our sample numbers. So if you go to Analyze, Descriptive Statistics, and Explorer,
Uh-huh.
so our dependent list, let me see if I remember how to do this, is, I might do it backwards first. Our dependent list is wages, and our factor list is gender. So you'll highlight wages and then click your arrow over for dependent list, and then highlight gender and click it over for factor list. And we'll see if I did it right. And click OK.
Uh-huh.
And then that should give you a mean, a 9.759. Yeah, it did. Okay.
Perfect.
And your standard deviation.
Right. Yep. Where's it? 3.169.
That is not what I wrote down. Did I write something down wrong? I must wrote some down wrong.
There's so many numbers on here. It's hard to sometimes
Right.
differentiate. Yeah, I wrote.
Oh yeah. So for the females, it's 3.169. So the top one is for females. Can you see there's an
Oh.
F? So
Yeah, I do.
your standard deviation.
Oh.
And then for the males. So you're gonna have it for first for your females and then for your males. And then at the top, the case processing summary box, that N is your sample size. So females is 91 and males is 80.
Okay. Okay. Okay, cool.
And then you're supposed to do a histogram. So if you go up to graphs, legacy dialogues, and histogram, we want
that's what I was doing. I was trying to go to chart builder. I don't know. I was just struggling to figure out. It wasn't letting me make it.
Yeah, so graphs, histogram, your variable is going to be your wages, and your rows is going to be, what, that did not work. Wages, and your row is going to be gender.
And will there be anything for columns?
No.
Okay.
And then you'll have a graph for female and a graph for males.
Okay, yep, got it.
So then that will describe the data. That'll give you all the information to describe the data.
Okay, awesome.
For make inferences, what type of hypothesis test is appropriate? It's an independent sample. because we have two different, we have males and females, we're comparing, or we have males and females. And then it says, are the requirements met for this test? So the sample size is large enough so we can assume it's normal. But it's not a simple random sample.
Okay. Then, okay.
To compute the test statistics, we go back up to analyze, compare means, and you're going to do independent samples t-test.
Okay.
And your test variable is wages. And then your group variable is gender. And we want to define the groups. So group 1, we can make male, so M. Group 2, you can do F for female.
Okay.
And click continue. And then you click OK.
Okay. Cool.
And then on this one, we're using the row that says equal variance is not assumed.
Okay, let me see.
Under independent samples test.
Why did I not see it anywhere? Let me open it up so I can see it better.
So it should be underneath your histograms.
Under that it says t-test.
Does it say independent samples test?
It says the independent samples table is not produced. I don't know what is wrong.
So try again to analyze.
Okay. Compare means, independent samples.
Yeah.
Yeah, wages and the test variables, gender and the grouping variable. Define groups.
Just put M in group 1 and F in group 2.
I did it, and it's not doing it. I don't know why.
Let me see. Let's go see.
Because I did all those things, and on mine I have, so right under the histogram. Yeah. Test groups equal gender. Missing analysis, variables, wage, criteria, CI. A little under that,
Okay.
it says,
See
what?
if it will, if you can, I can share this with you. Okay. That's not what I wanted you to see. Let me find. Where's it at? Analyze. Let me put this up, and so then you can look and see if it shows the same thing. Okay. Okay, so does yours look like this down here, gender with the parentheses, male, female, and the grouping variable? Can you see that?
Yeah, that's how it looks.
Hmm.
Okay, you can just we can just keep going and just
Okay.
talk about it because I have no idea. Like, it looks just like that, and I followed with you.
That's weird. Wonder why.
But the answers I got earlier were the same that you
Right.
got too, so I don't
Right.
know. It's really
So
odd.
okay, so what what should have showed up was, where'd it go? Now I have so many boxes opened.
Yeah.
It's like, I gotta find where it went. Um, okay, there it is. Just I'll show you this just so that you can see what it looks like.
Okay.
Um, okay, so you'll get something like this, and we're gonna look at, I don't know, is this showing on your screen? This equal variance
Yeah, I can see it.
assumed,
Uh-huh.
and then so then the score is this bottom one, 1.836, and the
Okay.
is the 98.263.
Okay.
And
Cool.
then confidence intervals is the 0.17. Well, you do 0.18 and 4.5253. So that's what it'll look like when it works.
Right.
Um, okay. And then, so then we compute the p-value and compare it to the alpha level. So the p-value was 0.069, which is greater than 0.05, so we failed to reject the null hypothesis,
Okay.
which means we have insufficient evidence to conclude that there's a difference between male and female mean ranges. So at the 95% confidence level, that's where you got the negative 0.18, the intervals there.
Okay.
And then, so we're 90% confident that there isn't any difference.
Awesome. I wish that would. That's weird that didn't work for me, but oh well. Sorry.
Well, maybe if we have to do it in the quiz, it'll work for you in the quiz.
True.
All right, shall we try the quiz?
Good. You know, the teacher is still giving me zeros for all of the group meetings, and I know I didn't attend the last one, but I emailed him and he still hasn't. He did never email me back or change them, so my grade is just going farther down and farther down.
Oh, yeah. I didn't email again. Was it this class where he said he was having email problems?
Oh, I don't remember him saying that. Maybe he did. Maybe
I
really.
double checked. There was. I think it was this class that he had mentioned he was having some problems with his email.
Oh, okay.
So.
It's okay. It's okay. So, are you on there
Yeah.
for
On the
okay,
quiz.
so sorry, I just had this. Okay. What requirements must be checked? Oh my goodness. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. So is that a simple random sample was drawn? Does that have to be? I'm probably confusing it with the other.
No, I think that's right. Simple random sample and X bar is normally distributed.
Because the sample size doesn't have to be the same, right?
No. That's the difference between this and the paired data.
Right.
That they're from two different groups.
Okay. Cool.
Okay. The test statistic for a hypothesis test comparing two means with independent samples is a T-score, right?
That's what I was going to say. Okay. Two samples are independent. Knowing which subjects will be in group 1 determines which subjects will be in group 2, or knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yeah, the second one.
Okay, well, yeah.
Okay. The next 6 questions use the data file dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls. Let mean one be the mu1 be the mean bill at the Idaho Falls office, and let mu2 be the mean bill at Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls, oops, my thing just covered it, is less than the mean bill at the Rexburg office, which means we have the null hypothesis. mu1 equals mu2, and the alternative hypothesis mu1 is less than mu2. Use the level of significance alpha equals 0.10. Okay, so what is the freedom?
I just tried to open that one, but it isn't in those other. I download this or whatever, the dentist office bills. Do you know what I mean?
Say that again?
The dentist office bills data file.
Uh-huh.
Not in the is it in the original ones that we got? Couldn't find it. Do you know what I'm talking about?
No, it's just here in the quiz.
Yeah, when I try to open it, it just opens up into Word.
Oh, really?
Yeah.
Oh, mine opened up in SPSS.
I do not know what's going on with this. Once this opens up.
Try clicking at the top. Did you click it at the very top?
No, I did click on it in the bottom. Let me see.
Try clicking on it at the very top of the quiz. Maybe it'll download differently.
No, it opened into Word. Oh, really weird.
Strange. Like download it again, right click on it, and see if it'll give you an option to open it in a certain program and select.
It says, all that it says is you don't have permission to print this page when I try to right click it. Weird. Dang it.
When you download it, when you download it, is the icon different? Like, does it? I don't know. What kind of computer do you have? Is it a? Okay. Yeah, I have that.
It just goes right onto Word.
Yeah, that's kind of weird.
Both of them do.
Well, we can just use it with mine. Mine opened up in SPS, so I'll
Okay.
just walk you through what I'm doing. So, I can, let's see, I can share my screen again. I'll just share the entire screen, and
Okay.
I don't know if that'll work. We'll see what happens.
Yeah,
Really?
I can see it.
Okay, you can see it?
Mm-hmm.
Okay. Oops, wrong one. Okay, so it wants to know degrees of freedom. So that one was, I think that one was, well, we'll just do this one. Okay, so, oh wait, this isn't gonna work.
Do you first do the analyze, explore, that one first?
That's gonna get us, that's gonna get us the mean, and the standard deviation, and the sample.
Mm-hmm.
But we want the degrees of freedom. So that one is, I believe it's this one. So the test variable, and then the cities of grouping, we want, group 1, we want Idaho. Group 2, we want Rexburg.
Mm-hmm.
And so it's not letting us use that. So try this. Group subcommand specifies an unknown variable for a long string variable. This command, let's try the whole name. Try it one more time. Campus build, the city, define groups, and falls, at Earth. Well, what does it want us to do?
No idea. No idea.
A numeric variable or a short string variable? Well, I tried a numeric variable, right? I did 1 or 2.
Uh-huh.
And I tried I or R. Oh, for crying out loud. Oh. Well, that's not helpful, is it?
Sheesh.
Let me stop for a second. This might get. Let's see if I can find it. How to do it. Sorry, I muted it for a second. So I'm looking to see if I can figure it out. So hold on one sec.
Oh, you're good.
Okay. Okay, Okay, so this one's like the homework assignment. I mean, not the homework assignment, in the, what's it called?
Preparation
In the
assignment.
book.
Okay.
So we have to change, we have to recode.
Oh.
Didn't have to do in the homework assignment.
Oh, okay.
And now we have a 1 and a 2.
Okay.
Then office 1, office 2, continue. Okay. There. Then our degrees of freedom are 37 point. Well, it's 37.996. So if you round that up, you end up rounding up to 38. Right?
Well, it says to 3 decimal places. So it would be 37.997, right?
Well, it just gives us 37.996. Well, I guess if I could double click on it, what is it?
I guess it'd probably just be 6 then.
Right, yeah.
Yeah. Thank you for figuring that out. Sheesh. Frustrating that so much has to be changed for that.
Yeah. Well, yeah. Well, you know, it's like homework isn't the same what you do on the quiz, isn't the same what you do in the book.
Yeah.
You know, nothing, it doesn't all match. So it's like trying to remember what you have to do when and where, and
Yeah.
didn't match the book, so I had to go somewhere else to figure out how to do the homework, and then now
Right.
do something different for the quiz. It's like, oh my gosh.
Yeah.
I remember when and where. What is the sample standard deviation for Rexburg? Okay, I'll share my screen again so that you can see what I'm looking at. If I can find my, once again, I have so many things open. Okay. What is the sample standard for Rexburg? So the standard deviation for Rexburg is 206.637.
206.637, is that what you said?
Yeah, 206.637.
Okay.
What is the test statistic? That would be a negative 0.434. 2. Then we have to divide by 2 because we're doing less than or greater than whatever it was, right?
Mm-hmm. Yeah. Is less than the mean bill of the expert office.
All right, so it's 0.33. Times it's 0.666.
Okay.
So what is the correct decision based on this evidence? So it's greater than 0.05. Wait, what was it? It's 0.10. So it's
1, 0. So it's, where are we?
greater than 0.10.
So
yeah, you failed to because it's greater than.
right. Okay, suppose instead that you had used the alternative hypothesis, what is the correct decision based on this evidence? We have sufficient evidence that the mean dentist bills between the two cities are different. We have insufficient evidence. We have sufficient evidence that the mean dentist bills between the cities are the same, or we have insufficient evidence that they're the same.
So if mu1 does not equal mu2, we have sufficient evidence the mean dentist bills between the two cities are different, right?
Are different. Yeah. Okay.
Gosh, that was crazy. Wait, before I do this, I'm going to do something real fast to make sure that I have these numbers right. Wait, that's not what I want to do. I'm just going to make sure when I changed it to those office numbers, that didn't change any of these numbers.
Okay.
And it did not. Okay. All right. So let me get out of this. And then bring that up. Okay. So let's bring up the next one. You want to see if that one will open up for your freshman dinner?
I tried and it still opens up in Word.
Weird.
I don't know why. I can read it though. For the next 6 questions, use the data file freshman dinner. This data represents the number of times freshman students from Utah and Colorado to cook their own dinner in a month. Let mean 1 represent the mean number of times a month that a student from Colorado cooks dinner. And let 2 represent this mean for Utah students. You suspect that freshmen from Utah cook dinners for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is mean 1 equals mean 2. Use this level of significance of sigma equals 0.05. What is the appropriate alternative hypothesis? Does not equal, right?
Yes. So let's first transform this. So we want to I'm going to change the variable to, it already says state. I change it to, I'll just copy states.
Okay.
Okay. So the test statistic, I'm just gonna do everything real fast. So I'll do explore, the dependent list. Okay, and then we want sample test. We want the test variable, the copy state, and define groups. Group 1, group 2, because for some reason we did it backwards. Okay. All right. So, what is the test statistic? The test statistic is 0.845.
Okay.
So what is the p-value? P-value is 0.410. We don't have to do anything because it's a two-tailed test.
What decision do you make? So it's 0.05. So we're gonna fail to reject it since it's bigger, right?
It's larger, yes.
And determine a 95% confidence interval for mean 1 minus mean 2. An estimate for the difference between mean 1 and mean 2. Input your answers below. Determine the margin of error for the 95% confidence interval.
Okay, so where did my thing go? The confidence interval is negative 2.204. Well, margin of error is,
yeah, the margin.
so we can go 5.137 minus negative 2.204 equals
7.3
divided by 2. So the margin error is 3.671.
Input the lower bound and then input the upper bound.
So negative 2.204.
You say 2.204?
Negative 2.204.
Okay.
And upper down bound is 5.137.
Okay. Awesome.
Oh, I am not confident on this test, this quiz this time. You got them all?
Yeah, I got them and I submitted it. We got a few wrong. Number 9 wrong. And number 11. Number 13,
What did you
17, and 8.
What did you put for 9? Because I got it right.
Sheesh, I must have not. I put 0.666.
No point. Oh, sorry, 0.333. We had to divide it in half.
Oh my goodness, sorry. Well, I'll just anyways. Okay. Did you get the other ones wrong, Lo? Number 11
Yeah. So number
and 13.
okay. All right.
None. That's it. It's left over.
All right. So what do we do wrong here?
There you go. Six or 37 point and 6. So for 11, use the alternate. Would we have insufficient evidence that the mean dentist bills between the two cities are the same for 11?
30 second. Way ahead of me.
Oh, sorry.
Okay, so number 11, suppose instead that you had to use the alternative hypothesis, mu1 does not equal mu2. What is the correct decision based on this evidence? So if the p-value is 0.33 does not equal mu2, which was
So I think it would be we have insufficient evidence that the mean dentist bills between the two cities are the same. Right? If we use that alternative hypothesis that they're not the same, then we don't have the evidence. Because before, what did we say? We said we have sufficient evidence that the two cities are different.
because it's still oh right, because it's still the p-value is still greater than 0.0.
Mm-hmm.
That doesn't change the fact that we failed to reject the null hypothesis.
Right.
And so we have insufficient evidence that the mean dentist bills between the two cities
Are the same, right?
are different, because we're saying the alternative hypothesis mu1 is not equal to mu2.
Okay, gotcha.
right? Or is it, okay, wait.
Well, but don't we know that they're already different?
Posen said that you'd use the alternative hypothesis. What is the correct decision based on this evidence? We still reject the null hypothesis. We failed to reject the null hypothesis. We have insufficient evidence that the mean dentist bills between the two cities are the same.
I really don't know.
Right, because we're,
Do we know the other mean though? I don't think we figured that out, right?
no, but what we're trying to figure out in that one is if they're different with this hypothesis. So with the one before, we were trying to figure out if it was less than. Our question is, is it one is less than the other? And this one we're trying to figure out if they're different. And so we failed to reject the null hypothesis that they're different.
Okay.
Right?
Yeah, I think you're right.
Okay, I'm not 100% positive in that one, sorry.
Oh no, you're totally fine. I'm not sure either.
2, 3. All right, so number 13, what is the test statistic? So it wasn't 0.845, so what did I do wrong on this? So I'm not really sure what to do on these last ones because it says 0.84 in the, hold on, let me check, I guess we can look at his class meeting from last year and see if my SPSS is not calculating it right.
Okay, yeah. I mean, we calculated the other ones right though, which was weird.
Yeah, well, let me go check it because, hold on.
Okay.
Diagnosis, one for
I'm
either
gonna
first
turn you
impression
down.
expert. Now, independent samples and select the desired test variable. Another is our grouping groups.
Well, it looks like they use a different one.
Could it have, did we need to round it?
What's that?
Did we need to round it?
I
The
opened,
test.
I opened it up and it's rounded already. I mean, like, where'd it go? It's 0.447. So that makes it 0.845.
Huh. What if we put that 0.447 in there though instead? Will that do anything?
I'm gonna run it again and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what?
Hey, Lena, I'm getting I have a migraine. It's getting worse and worse. I think that I need to go before it gets too bad and I can't function today.
Okay. All right.
Sorry. Thank you for all your help.
Yeah, no problem.
Good luck figuring that out.
Okay.
Okay, bye.
Bye.